And read engine disassembly and cleaning. You want to make sure that everything's clean before you start to remove, that all your tools and equipment are organized and ready for you, that you have removal procedures based on OEM recommendations, typically in Mitchell. Adhere to all safety guidelines. Are relatively common sense, but you need to be careful. And you can use a digital camera or camcorder to record locations and connections, in addition to numbering wires, hoses, color coding them so they all go back together rather seamlessly. Engine removal preparation video. You're going to be watching that before you have your regular PowerPoints in Canvas.
The first step in preparing to remove an engine is putting on a pair of protective glasses and then placing the vehicle in an area of the shop with enough flat and level space to safely hoist and secure the engine on a cradle or engine stand. Once the vehicle has been positioned, secure it by placing wheel chocks against all four wheels. The next step for many shops is removing the hood. In some cases, it can interfere with removing the engine. Once that's finished, inspect the engine hoist as a safety precaution, and then hoist the engine to a secure location. With the engine removed, the last step is to remove all the liquid from the engine before moving it to the machine shop. Keep in mind that the oils, solvents, and sealers that you'll find, both in and around the engine, are in fact dangerous chemicals which can easily be absorbed through exposed skin. So before you begin removing any liquid or cleaning grease and dirt from the engine, make sure to put on a pair of protective gloves and OSHA-approved safety glasses.
Okay, so we have the draining of the fluids, which can be done with the vehicle with the engine in. You can also do it with the engine out. I would prefer to take as much out before I move the engine. That's just personal preference. General removal procedures. A battery saver. We have these OBD2 plugs that have two pins in them that'll keep the body control module and the ECM powered. It will work on some vehicles. It will not work on all vehicles, so you better check with your OEM specifications, because they are problematic with certain vehicles. And remove the hood, drain fluids, remove oil filter, linkages and electrical connections. I generally label everything with colored tape and numbered tape and tags and colored zip ties. Remove all air intake components. Okay, labeling for reassembly. And disconnect and close off fuel lines. Make sure your fuel lines are way above the tank level. There has been some instances where there were fires because of fuel leaking out of vehicles. Label and disconnect vacuum lines, drive belts, power steering, heater, radiator, and exhaust. Engine removal.
Pulling an engine is one of the more grueling tasks that you'll perform as an automotive technician. Before removing an engine, always disconnect the battery first. Remove all fluids, hoses, harnesses, cables, and linkages. And don't forget to label them for easier installation later. Next, remove the bell housing cover in order to remove the torque converters to flywheel bolts on automatic transmissions. On manual transmissions, pay special attention to straight alignment upon removal. In order to safely pull the engine, you'll need a lifting chain. The lifting chain should be rated to hold at least 1,500 pounds. The chain is attached diagonally to both the front and back of the head using a grade 8 alloy steel bolt. Once the bolts are secure, tug on the chain and check for any component that might be interfering with the movement of the chain. If you find one, loosen it and steer it clear from the path of the chain. Next, make sure that the space under the vehicle is clear of debris, and then move the engine hoist into position and hook it up to the chain. At this point, the engine isn't free from the transmission. Use either a transmission jack or a standard jack supported by a block of wood to hold the transmission in place. Keep in mind that you aren't raising the transmission. The goal here is to prevent it from falling once the engine has been removed. Once the jack is in position, you can go ahead and remove the motor mount and bell housing bolts that are located on either side of the block. After these bolts have been removed, the engine should pull free of the transmission. Next, check to make sure that the engine is free and clear of any components, and then carefully raise the engine, staying clear of the firewall, wires, and the radiator support as you go. After the engine has been raised high enough, it can be pulled forward and away from the vehicle. As a safety precaution, no one should be under the vehicle while an engine is being removed. Once the engine has been moved to a safe working space, set it on blocks, a set of dolly wheels, or attach it to a motor stand. As always, all loosened bolts should be properly identified, labeled, and placed in a bag or container for use during the engine reinstall.
Front-wheel drive vehicle engine removal. Typically, the transmission and the engine comes out on a subframe after disconnecting the drive axles. Some can be removed from above if there's enough clearance, but most of them do come out from below, engine and transmission together. Here they're showing in case you do have a top removal that you need to support the transaxle if the engine's going to come off from the top. And you have to remove the axle shafts. Axles can be pried away from the transaxle, and steering knuckles are disconnected from lower control arm. And if possible, they're showing this one coming out through the top. Leave axles connected if necessary. Most of us take the axles out of the unit. The engine's removed from above. The connections and components are separate from the engine and transmission, so motor mount connections, and always have to have that transmission supported, because that could be a problem if the transmission was to fall out. Once removed, you want to put the engine on an appropriate engine stand, and you want to disassemble, make sure that you're looking for any parts that may be worn, and you have your service procedures from the OE that you got out of Mitchell or a manufacturer's platform. You're always going to have some debris and some sludge on the intake side and the exhaust side of the engine, so be prepared to do some cleaning. You want to make sure that you identify the timing marks that are on the cams. Here they're showing the timing marks in the area here of the cast in to the gears, and you want to align them and maybe mark the crankshaft. You could mark the crankshaft and the cams, and make sure you have your relative position for top dead center for number one. Push rods, rockers, and assemblies have to be kept in perfect order from which position and what cylinder they came out of. Otherwise, you're going to have a problem. You want to hang on to your gaskets. Make sure that the gaskets that are in your replacement kit are identical. Occasionally, you'll see a mispacked gasket set with perhaps a missing or wrong gasket or O-ring, and that could stop the job. So you want to make sure you retain your older gaskets. This is actually the torquing example. There's a typo here. It's the reverse order of this, because you'd be starting from the outside, going from the inside. And typically you could go one flat, and you could actually check the torque that way if you want. But it's a way to get the tension, the bolt tension and clamping forces gradually off the cylinder heads, because typically they're going to be aluminum and they're subject to stresses that cast doesn't have. Cylinder head removal.
Begin by removing the bolts that hold the cylinder head cover in place. Then place these bolts in a marked bag or organizer tray. Next, remove the cylinder head cover and gasket. If you find the gasket stuck to the cylinder head, you can use a gasket scraper to detach the gasket from the head. If you're working on a V-style engine, it may be necessary to mark the heads if they aren't left or right specific before reinstallation. And if you're working with an engine stand, you'll want to make sure that the safety pin or bolt is in place, so that the weight of the engine doesn't shift dramatically as you remove the heads. Once the head and gasket have been removed, you can begin removing the cylinder head bolts. In some engines, the cylinder bolts need to be removed in a certain sequence in order to prevent the heads from becoming damaged. So check the manufacturer's guidelines before removing these bolts. Heads themselves are often stuck to the block, so be prepared to use a pry bar or rubber mallet to loosen them. If you're using a pry bar, insert it into an area that will give you the most leverage without damaging other components, and give it a slight push. Once the head is loosened, gently place the fingers of one hand in the intake ports and the other in the exhaust ports and lift the cylinder head. After the head has been removed, scrape the surface to remove any debris and inspect it for damage. Look for cracks, gasket problems, and burned valves on the head. You'll also want to use a straight edge and feeler gauge to check for cylinder head warpage.
Everybody should know the reason here, why we want to, frequently we're going to have to detorque the head in the reverse sequence. Cleaning engine parts. Disassembly and parts should be thoroughly inspected and cleaned. Some shops have a breakdown area and wash tanks in one area along with the wire wheels and grinders so that all of the debris and dirt can stay in one area. It's problematic if any of the dirt that you're cleaning ends up on your assembly bench. All sorts of water-soluble organic rust and scale. Scales typically in the coolant passages on an engine. We'll have a little bit more about that later. Rust is just oxidation, and water-soluble is basic. Organics is essentially your oil and your byproducts of oil residue. We have chemical cleaning, thermal cleaning, and abrasive cleaning. All of them have a place, but we have to make sure we have safety procedures and we understand what the hazards are for each cleaning method that we're utilizing. Chemical cleaning can remove quite a bit, but we do have concerns with breathing. We have concerns with getting any of these reagents on your skin. We have to be careful with those compounds because they are toxic. Okay, parts washers. A variety of them out there. Hot and cold soak tanks, they have improved with the environmental side. The Aussie juice tanks that we have in our shops are less invasive for in terms of chemical and hazards. This is a caustic soda wash tank. Very few of these around, but they basically heat the water up to 200 degrees. And they have the caustic soda in there. It's the only method that'll remove the scale from the coolant passageways when engines get the residue inside the engine block. So cylinder heads and engine blocks would be cleaned in caustic soda hot tanks. Thermal cleaning is just essentially putting a lot of heat in there and basically baking off the dirt and other contaminants. Here, the exhaust coming out of the heating oven is a concern, and in some cases they have to be scrubbed. Abrasive cleaners, we have shot, grit, we have sand, and we have glass beads that are used in tanks with compressed air. Ultrasonic cleaners are pretty passive and safe. Citrus cleaners, traditionally, they used to be very powerful. They were very caustic and corrosive unless they were diluted. So when they first came out years ago, they were very corrosive. But when they're diluted, they're safer to handle. The salt baths, molten salt will dissolve, but this is more of a industrial application for a specialty rebuild shop. Most shops are not going to have caustic soda tanks and salt baths. Cleaning has become more which type of engine cleaning is more popular? The least dangerous one. Clean parts should be carefully inspected. Cracks from pressures, temperatures, fatigue, and impact, and of course, engine overheating. Thermal stress will show up with heat effect. You'll see a light blue or a brown if it's worse. But metal will change color when it has heat effect, and temperatures that approach the tempering of metal when it's made. So when it changes color, it's definitely is not as strong as it was, and it's lost some temper from the original manufacturing processes. Crack detection.
Properly inspecting an engine and its components is something that is continually performed throughout the disassembling process. For many technicians, the process begins by looking for wear or hairline cracks on the cylinder head. These can be very difficult to see, so many repair shops use two processes to help locate hairline cracks: magnafluxing and U-dye. In magnafluxing, an electromagnet is placed on the head. Next, a dry magnetic powder is applied. If a crack is detected, the magnetic powder will fill in and stick over the location of the crack. In some cases, U-dye is used to detect cracks, especially in the case of aluminum heads. U-dye is sprayed directly onto the part and detects any cracks or surface gouges as it dries.
The dye penetrant and the mag particle processes are important. Of course, there's always places in the engine block and the cylinder heads where they can't be assessed using dye penetrant or a magnetic particle. So you do your best on any of the mating surfaces and move forward with the job. A cracked lifter bore, it will create multiple problems here if the lifter turns in the bore, and you'll have not only leakage, but you can have additional damage to the block and the lifter itself. Crack detection, pressurized air and water, mag particle, and dye penetrant, very popular. Magnetic crack detection, we'll be doing this in shop. You'll see how this works. It's pretty straightforward. It's good for ferrous metals that have magnetic properties. And dye penetrant will work on ferrous metals and non-magnetic metals like aluminum and brass. So dye penetrant will cover just about every metal that's utilized in engines. In vehicle service, oil pan gasket, vibration dampener, and cylinder head replacement.